Having fun?
Yeah!
Oh, James has been having fun. How come no one else has been having fun? Did you go to James's talk? Wasn't that fun? No? I was there, James. I was there. I came 3 times to your talk.
Yeah, you left 3 times.
And I left 3 times during your talk. That was great. It was great. Who learned something new so far? Almost everyone. Great. Come back tomorrow. You'll definitely learn something new. Let me see. Sachin is coming up first. He's ready, but we still the door's closed. Is everyone here? Everyone's here? Okay. We're set to go. Sachin, I think we need a mic adjustment. You didn't want to hold it?
I'll hold it, yeah.
Hold on to it.
So everyone can hear me at the back?
All right, Sachin will be presenting first. Again, these are lightning talks. You have 5 minutes. At the end of 5 minutes, James is going to start applauding, and everyone just join in. If they're still talking, clap louder. And eventually, we'll pull them off and cut their microphone. You only get 5 minutes, and then it's done. That's it. We'll move on to the next person. Next person is Rob P. Wherever you are, if you can be ready to jump up. Right there. Excellent. But first, we have Sachin, who's going to talk about deep and easy learning.
Yeah. So my name is Sachin, and so I've done a PhD in machine learning. But I guess these days I've been moving a bit more into the deep learning side of things. Right, so just to give you an idea of what it is, I'll talk about the most simplest case first of all. There's only one layer, and forget about this F, right? So what we want to do is weight it so that we get the output Y. And we keep adjusting the weights. When we have a hidden layer, what we keep doing is the same idea as here, except we stack them. And we want to adjust them until the output seems about right? So we try to minimize something, some sort of given metric. So in this talk, I'll be introducing Keras. So it's a really good deep learning library. It makes it a whole lot easier than what we had so far. So in this case, what I want to try and do is, I have this function y equals x squared, nice and easy. I want to try and learn that. Okay, so in this case, I'm not trying to split this up into test and train. That's not really the point of this talk. It's just to show you that Keras is easy enough to do. I divided by 25 because that's the maximum, just because it's always nice to be between 0 and 1. And by the way, this will be in my GitHub repo later on. Yeah. Okay, so what you end up doing, I hope you can see this, is we create this thing called sequential, right? So all this is imported from Keras, and then we add a layer. So in this case, there's only one x, which is why the input dimension is 1, and then we output 1, right? So, and with the optimizer, you can call it whatever you want to, and then we're minimizing this MSE error, right? So once we do that, because I only have one thing, this is what I get, okay? So y equals wx in this case, right? So I only have one weight. Because of that, I get one straight line. So now I'm going to change that to 2, right? So I have 2 of these things, two nodes, and in that case, when I do that, I get a slightly wonky thing, right? So in this case, the f thing which I ignored was a ReLU function. Okay, so it really doesn't matter what that activation is too much, but the point is you got 4 lines of code to get this neural net, right? I can keep adding these layers. I've increased it to 32, no particular reason why I chose 32, but once I do that, it's still not getting that much better, but we're starting to see the shape, right? The whole idea of deep networks is that we're adding more and more layers. How much time do we have? 2 minutes, right? Okay. So before we clap, don't start early. Yeah, so I've added 2 layers, and I get this nice y equals x squared function, right? So the more and more layers that I add, it'll turn out to be nicer, right? Now, if I was to do this in TensorFlow, just to show you the amount of code that I had to write to get the same thing, that's the amount of code that I had to write, right? So Keras makes it like 4 or 5 lines of code, and you get the output. And the other thing that I really didn't mention is that you don't have to do backpropagation manually, right? So this takes care of everything. Well, TensorFlow does it as well, but Keras is a layer on top of TensorFlow or Theano, and makes it a whole lot easier. If you go to the repository, there is another thing called LSTMs, if you want to take a look at it. But in this deep learning notebook, it's just the basic things that you have. So, and these are the references. And questions?
No questions for a lightning talk. Let's clap. Thank you very much, Sachin. So I have been asked in between each talk to tell some jokes. Come on up, let's get started. The quicker we change over, the less jokes you'll hear. I'm not much of a comedian though, so instead my joke is going to be little bits of, I guess, my background and stuff that I want to talk about. I voluntarily use Windows, which I guess qualifies as a joke, but it's true. My name's Steve Dower, I actually work for Microsoft, and I'm the Python Windows build master, largely responsible for that. So as each break comes up and I have a chance, I'm going to tell you a little bit about Python on Windows because they gave me a microphone and no one's going to tear me down from up here. So I'll use it, but right now, are you ready, Rob?
Yeah,
Am I going to start?
It's showing my screen totally wrong, but that's okay.
That's all right.
I'm going to pretend this all works seamlessly, right?
Just pretend everyone else can see it as well.
Oh, yeah. So this is my
Awesome.
talk.
Works. Isn't that the Microsoft slogan?
It must be an operating system, probably, yeah. All right, Rob P. is going to talk about DigDag, Cloud Data Workflow Management.
Okay.
Take it away.
Thank you. So I'm going to talk about DigDag. It's a new open source project from Treasure Data, created by Sada, who's in the middle of the room. So to go through my talk, I'm actually going to go through a DigDag workflow, and actually it's going to open up slides as we go through. So we'll see if this is magically work. So let's load up terminal. And so the goal with DigDag was to provide an intermediary option for easy to get started, but still powerful for more complex use cases, and for managing workflows either locally or between distributed systems in the cloud. We chose to use a YAML-based configuration system so that you can get started easily. And of course, the terminal is over here, so I'm going to run DigDag. And so, and of course it pops up over here. So DigDag allows you to build repeatable data pipelines. You build it as code, run it in the cloud, or run it on other systems. We liked code because for all the nice reasons that GitHub gives you. And again, the wrong screen. So why would you use DigDag? Well, let's say you have Python and you want to coordinate Python jobs with other cloud system processing. As data becomes larger, we're using cloud systems to allow us to collect data at scale, run processing on Redshift, BigQuery, analyze data that's in S3. How do you manage dependencies when it's not all always on your computer? So that's what we wanted to solve. Simple to get started. Develop locally and then push to the cloud. And so anything you can do in the cloud for managing this workflow, you can also do on your computer. And so that way we wanted the dev and prod switch to be a core element of what we created. And then powerful for advanced use cases. You can create tasks programmatically, SLA emails, error notification, parameterization, and task-to-task or workflow-to-workflow dependencies. Run on Python, Ruby, Postgres, Treasure Data, Spark, BigQuery coming soon, and so you can run any options you want. And so if I make this a little bit smaller. So what we've been going through is a simple workflow. It goes top to bottom. You can also define it as a DAG, but this is defined as groups of tasks. And so we've gone through, we're running a Python to allow us to wait between tasks, and so you can pull in a method and run it as part of your workflow. And so right now, actually, it's running a query in the cloud, and it's running one of the more advanced use cases that we described, which is data validation. We see that across a lot of our customers. And that's how I know if I'm running behind. And so in this case, we actually run a SQL query, store the last results, check to see if those results are under a certain amount, to see if we have the amount of records that we would have expected during a day, for example, and then we can send an email if that's not the case. What you're seeing is an example of us grouping tasks, and so this is one of the options in addition to defining the DAG dynamically, because for a lot of our customers and users, we found that they liked to be able to organize their tasks, not only based on direct dependencies, but actually based on the part of processing that was occurring. This is where all the preparation occurs. This is all where the analysis occurs. This is us sending it to a machine learning model to be trained, and then this is us deploying it to run into production. And so rather than having that not be explicit, they want to explicit and define it dynamically. Another option, so you can host, this is an open source project, you can use it, run it locally, host it in the cloud, manage workflows across many systems, but you can also just deploy that workflow to treasure data. So this is, is going to be a new offering for us, and so if you don't want to manage the server, the metadata store, the database for your workflow processing, you can use treasure data. But if you want to learn more, this huge screen shows the digdag.io website. And so here you can learn how to create workflows. You can learn about the different operators we currently have available. We have a growing user base amongst our customers, but also people in the open source community. So if you have any questions about what you can do with this or why you might want to use it, happy to talk after. So.
Thank you. Do we have Kincaid handy? Yes, come on up. So, first Windows fact I'm going to throw at you. Python existed as Python for DOS before it was Python for Windows, which makes it about as old as Python itself. Because DOS was only, when did that die off? Before 95. Jeez. That's old. So Mark Hammond did the bulk of the work to bring Python to Windows. Still has a credit in the installer at the end. And we're still very thankful for him bringing it to so many more users. Kincaid has a very clever kid by the looks of it. And is going to be telling us about MyShake, the smartphone seismic network.
Yeah, I put this one here. You can see that actually I think I'm still a baby in Python community, or at least a toddler, because I only have 3 years experience, even younger than PyData. And so today I will talk about like the project I'm working on, MyShake. So we try to build a smartphone seismic network that using everyone's smartphone sensors, like accelerometers inside, to detect the earthquakes. So we collaborate with Digitalicon Silicon Valley Innovation Center, and also Moore Foundation funded us. So I'm from actually Berkeley Seismological Lab. So we know that we have earthquakes all over the world. You can see each of these dots is one earthquake. And we also know we have seismic stations to monitor the earthquakes, but they are very expensive. Like one site maybe $200,000. But if we can build a seismic network using smartphones, so we have millions of smartphones at almost no cost. So this is the goal of this project. And also we know the hazards of earthquakes is very high, like the showing here, the warm color here, you can see a lot of places, but they actually don't have seismic stations like Nepal, just to have an earthquake, but they only have a handful of seismic stations, maybe less than 5, but they have like 6 million smartphones in Nepal. So if we have that smartphone seismic network, we can actually build a warning system like to warn people before the large shaking arrive at Kathmandu. So, but you may ask, like we are carrying our phones every day, walking, running, and doing all kinds of activities. So if we record a signal like this is smartphone recordings, how do I know whether this is an earthquake or this is just like I'm jumping off the floor or something? So this is one of the first goal. So we collected data. So this is one smartphone data. I just want to give you a test. Can you tell me where is the earthquake? This contains a magnitude 7.8 earthquake at about 100 kilometers away from the outdoor. So you can see all these 3 component signals, and this is like the large signal here actually is like a human activity. So if we zoom in to this box here, you can see the earthquake actually is here. So what we are doing is that we try to find the characteristic between different motions and then build a classifier behind that. So this is another example of earthquakes. So you can see earthquake have its own features. So I don't have time to talk about that, but we can talk later. But we built an artificial neural network classifier running on the phone to detect whether this is an earthquake or non-earthquakes. And then, so we have millions of smartphones, so we can take advantage of that. If we have a network of smartphones during the earthquake, it will not be only one smartphone trigger or detect the earthquake. It will be like a couple of, like these magenta dots is the phones detect the earthquake. So this is why we can aggregate the results, basically doing a spatial and temporal clustering of these multiple phones. So this is actually the app we built. We have the artificial neural network classifier running on each phone, and then detect the earthquake. Then we have the cloud basically to classify, to do a clustering algorithm to locate the earthquake, and then we save the data into the database. So currently we have more than 200,000 people download. So this map is mimic the Earth night map, but it's actually the MyShake registered users actually light up the world. You can see we have a black hole in China because we don't have, people in China don't have the access to the Google Play Store so that they can't download the app. So anyway, in the last 5 months, we actually released in February. So you can see we recorded earthquakes all over the world. We recorded more than 200 earthquakes. So the larger size is like the magnitude is larger, and the color showing you different depths. So this way, we actually think that we can, in the future, to set up a really low-cost smartphone seismic network. So if you have ideas or suggestions, you can talk with me. So our address is myshake.berkeley.edu. Thanks.
Thank you. Was our next speaker coming up? Excellent. No slides?
No slides.
No.
Just a very quick announcement. Thanks. Hi all. I'm just going to take literally just 2 minutes. So I'm Sohaib. I'm a data scientist at Valor Water Analytics. We're a data analytics platform for primarily water utilities, also gas, sometimes electric. We basically look at water consumption data, and we help utilities identify anomalous events like leaks, meter tampering, water theft, that sort of stuff. That helps them reduce their revenue loss. And you can imagine, especially in California with the drought and everything, and especially with the government regulations that comes with it, you know, in terms of like water conservation, et cetera, utilities are especially sensitive about not losing money, you know, through these kind of like events. So currently we're hiring a data science consultant for a contracting position. We have lots of interesting problems to work on. We have lots of ideas that currently exist as just ideas, and we want to, you know, we need people to like kind of like just, you know, build that product through. So our tech stack is the usual Python, R, SQL stuff. So if that's something that you know, that might interest you, you know, fits within your experience, etc., just come find me. I'll be here for a bit more today, and I'll also be here tomorrow. Thanks.
Thank you. Mr. or Ms. Alpha Sheets, if you'd like to come up and start getting plugged in, I'll throw out the next Windows fact at you. It's been available for 20 years. Who thinks Python 3 is more popular than Python 2 on Windows? Congratulations, you're right. By every metric that I have available, which includes downloads from the Python.org site, which includes people using it in Visual Studio, which includes crash reports, Python 3 is actually more popular than Python 2 on Windows these days. So we are making progress. We're getting to a much better place for the language as a whole. And my next fact after this talk, we got signal coming through? I have more time to fill in?
I plugged it in.
We got a... Anyone know how to fix... This is Ubuntu, right?
Yeah. Thank you, James.
Wait, give us a second. If this doesn't work, then what we're going to do is keep killing time.
Oh, no. I'm letting everyone be very entertained by this. Because everyone with a Mac and a PC has had a working projector.
Thanks.
So the other cool fact that you may not know, this is fairly recent development, and it occurred to much cheering around the office for us.
I have it in my bag.
What do you think happens if you type pip install numpy on Windows?
This is a Mac adapter.
Should we just have someone else go first?
Who thinks that it blows up and explodes in all sorts of interesting ways?
Okay.
Who thinks it complains about not having a compiler? Okay, technical difficulties. Let's have Young Chen, I think. Young Cho. If you'd like to come up and plug in. Who thinks that it just downloads a wheel and extracts the wheel and you can have numpy on Windows by typing pip install numpy? Correct. The team that did that, everyone should buy them a drink because that's an amazing amount of work to get wheels together for numpy, but it has solved one of the biggest pain points that exists, and I mean Continuum did it first, but the team that used proper open source tools to make a wheel for numpy on Windows deserve a beer. The compiler that you used. Sorry. ICC, no, the iFort. Yeah. We got screen mirrored, not quite. So, while the young Cho is getting his screen together, we are going to hear about how to write and run biology using Python with robots. I hope. Sorry. Do any of the upcoming lightning talks have a Windows machine? We can skip to you.
So you just, yeah, but you disclose them.
Well, this one looks like a Mac as well, isn't it? So it's not guaranteed at this point, you know.
Tell us more about Windows, Steve.
No,
We're all
that's really not doing
dying to hear
anything.
about Windows.
So what app are you using? Sorry.
Oh, there we go.
Are you ready?
Oh. Okay. Hey everybody. Today I'm going to talk about basically running an experiment on the lab, like a web experiment, a biological experiment on the web. So first thing first is I work for Transcriptic, which is a cloud lab. So I'm just going to talk about a bunch of open source stuff we have and how we're integrated with the Python stack. So this is Transcriptic. Basically, we allow you to write any experiment and run it from the comfort of the web browser, and as well as basically run it using robotics. So if you can look at this, you can see this is like a work cell we have to run experiments. But what I'm going to focus on today is on how do you write this code. So this is all in Python. So in order to do that, we open source a standard for writing experiments called autoprotocol.r. And essentially, this standard can be used to specify any experiment, including biological experiments, chemical experiments, or any other kinds of experiments. So to go through this process, I'm going to bring up a demo notebook. And here, I'm just going to go through like a bunch of basics about autoprotocol. So here, I'm writing an experiment for qPCR. How many biologists are there in this room, actually? Cool, at least 2. Great. OK, so qPCR is a very common experiment run by biologists to amplify DNA, as well as to look at whether certain genes are present in the cell. So this is like a brief like sketch of a PCR experiment. So here I'm creating a dictionary of experiment. So here I'm creating a plate. I'm transferring some stuff from this plate to the other plate, and then I'm sealing it, and I'm running thermocycler on it. And then once I do that, I have this object, which essentially is a representation of this experiment. And with this experiment, it's now portable, and I can dump it to JSON, I can transfer it to anybody, and we can then run it after that. So here I'm creating a qPCR run object, and here I'm actually submitting a run. Oh, geez. Cool. And once you submit a run, you can actually see from, oh, this is a bit, well, let's see if this works. Okay, this is from doing it live. But here's some of the run, and you can see like the run project. And after that, you can do a bunch of stuff with this run, right? You can have like, analyze the results of this run. So here we are like accessing a data object, and this object basically uses all the common like common pandas stack tools. So for example, I can look at my data. So I'm fetching data sets here, which is the pandas data frame. I can dig into this data, for example. I can be like, oh, how does the first data set look like? So for example, here we have like embedded iframes, which you can then figure out what this data set look like. You can download this data set. As well as you can do a bunch of other interesting things. You can look at the instructions that consist of this data set. You can look at the data that was associated with these instructions, as well as you can also run a bunch of kinetics and open source analysis functions, which we use to basically analyze data and look at how the experiment went. So, yep, I think that's all the time I have, and thanks for having me. And just check out otherprotocol.org, as well as our open source libraries on GitHub/transcriptic, and hope you guys can contribute to it as well. Thanks.
Thank you. Is Matt Davis ready? Are you going to have another go? Let's have another go.
Yep.
And while we're getting set up again, I don't have a Windows fact for you this time, but since you stuck around for it, here's something that's not actually a fact. We don't have an official meet up and drink up tonight, but if we did have one, it would probably be at Thirsty Bear Brewing Company, 661 Howard Street. So just up the road, Thirsty Bear Brewing Company is hypothetically where we all may go and hang out and have a drink after the lightning talks are done. So if you happen to be there as well, we can hang out and have some fun. Are we good this time? Yeah. Looks good. All right. This is Alpha Sheets, collaborative programmable spreadsheets.
Yep. What the hell? Huh? Yep. Displays.
This one so it overlaps more than 2 mirror displays.
Mirror displays.
If someone would like to volunteer to do a lightning talk on setting up your laptop for lightning talks, that would be a great topic.
Why?
That it's a little late in the day for it, but
Yes!
put that down first on the list next time. All right, we're here. Please keep this configuration.
Oh my god. Okay, hold on. Wait. I'm gonna press the apply button. And everything's going to be just fine. Wait. The apply button.
Do you need to
Getting-
change the setting again?
Clicked. Hold on. It's wait for this.
Okay.
Wait for this.
Keep.
Hold on. Wait.
Keep
Keep.
Hey!
And that concludes the lightning talk. I'm just kidding. All right. So, I am Alex. I am the CEO and a co-founder of Alpha Sheets. So, what Alpha Sheets is it's a programmable web-based spreadsheet, basically like Excel or Google Sheets. So, for example, you can do cell references and copy-paste them down and do arithmetic on the references. The fun stuff is that you can also use Python, R, or SQL directly in the sheets. So what happens when we type range 6 here? Well, range 6 shows up. The Python code directly evaluates in the spreadsheet, and the value is here to update. So yeah, this is pretty cool. All right, what's this useful for? Alpha Sheets can be used to help collaboration between technical people and non-technical people. People who know how to code and do analyses in Python, and people who really only know how to fiddle around with things in Excel. So I'm going to just show a quick demonstration of such a program. So small display, disregard. We're hiring front-end people. So this is the global code editor where we include all of our imports and global functions. So I'm going to build a thing that takes stock data from a certain time frame and plots the closing prices and the moving average of those prices. So here, you can just put the date time object directly in the cell, subtract 180 days from it, and now we're going to pull the data from Yahoo Finance with the ticker and, holy shit, the ticker and the information, the closing and start date right here. So just with this one command, we pulled a Python data frame from the web and got all this opening, closing, volume information for Yahoo, for Google from this ticker over this time frame. Now, if you want to plot this information, it's as simple as referencing the close column of this data frame and pressing plot. Voila. Now let's say we want to find the moving average of what these prices look like. That's pretty easy too. So let's say the moving average we want to look at is 20 right now. We can just create a new column here and reference the close column and call for front-end developers. This should be referencing B4 here. And we have all the moving averages. These are all nans because this is a 20-day moving average. And if we want to plot what's in this moving average, it's as simple as just referencing this guy here and plotting that too. So there we have it. Quick and dirty analysis of stock prices and moving averages over some time frame. So what do we do with this? Let's say you want to share this with someone who doesn't know how to code. It's as simple as clicking a link. And shoot me off. And
Yeah,
you can change the ticker.
We are. That was the clapping.
Okay.
That's the clapping. That's awesome. I want to clap that again.
Thanks.
That is really cool.
See that? See that? All right. Sweet. Thanks.
That was totally worth fighting the monitors. All right. Up next, is this Matt Davis coming up? You, Matt? Excellent. Oh, he's brought his family. Awesome. So next Windows fact. I said before that I have the download stats from python.org, which is the main place where people on Windows get their Python from. There's some people at Continuum think that they're the main place, but it's actually python.org where everyone downloads it from. How many downloads a month do you think Windows sees, Windows versions of Python see? Let's 7. We have set. Do I have any advance on 7? Any advance on 7? Think 27. Any advance on that? This is per month, remember, not in the last minute. Is any higher? Can I have 1,000 from anyone? Anyone know 10,000? Yeah, I have 10,000 at the back. Anyone want to go higher than that? 15,000? Any more? 20,000? Let's go a little quicker here. Any advance on 20,000? Any advance? There's 100,000. 100,000 per. 115,000 per month. Can I get an advance on that? Any more? 115, 200,000 per month. Let's get 4 million per month. Anyone want to go above 4 million per month? Anyone?
5 million, but 3 of those million are you downloading it yourself.
How did you know? It is actually about 4.5 million downloads a month of Python for Windows from python.org, which frankly blew my mind. And my next set of facts is going to break that down a little bit more for you. But right now, we have Matt Davis is going to talk about SnakeViz.
All right, this is a really quick rundown of profiling in Python, which will conclude with SnakeViz. So when you want to make your code go faster, you have to know which part of it is slow and why it's slow. So that's where profiling comes in. Profiling is a tool built into Python that will tell you which functions in your code are taking how long. So I'm going to load a little bit of data. So the first tool, all of these things are built into IPython, is timeit. The timeit magic will run a thing a bunch of times and then tell you how long it took on average. Useful to know. This is really useful when you want to compare two things that do the same thing in the same like have the same result, but you want to know which one is faster. Note that it's not always, tests are not always representative. If I had more data in these data frames, these results might be different. So make sure you're testing it on something representative. But this is really handy. You can also, if you put 2% signs here, you can get a whole block and profile the whole thing. But that just tells you a number, which thing's faster. The prun magic actually gives you a table, a breakdown. It opened up in this little frame down here. These are all of the functions. This is how many times they were called. This is how long it took. They all went very fast, so all you see is zeros. If you actually want to get something back called a pstats object that you can read about in the standard library, you can use flags to prun to get that, and then you can do things like sort them and filter them to like the top 10. So this is the top 10 most frequently called functions. You can save it using the -d flag. You will save these stats to a file, and we'll come back to that. So that saved it in this directory to a file called filter.prof. Okay, SnakeViz. SnakeViz is not built into Python. This is a thing I wrote. So you have to install it and then lodax SnakeViz to get the magic. Now when I do this, it's going to do the prun thing and then open up this visualization of how long different parts of your program took. And so when you hover over these things, it highlights it, and then over on the left, you'll see the things like the function name, how long it took, stuff like that. You can drill down into this and get deeper into the stack to look for things. The way to interpret this is angular arc is what fraction of time was spent in that part of your code, and then as you, and this is getting deeper into the code, so this is higher level. You can also go with the icicle if you find this easier to interpret. And then it's got the names on there too. This table is the same information in the table that I was showing you in the notebook a second ago, but you can sort it here. It's handy. So that works in the notebook. You can also, say you have some code in a file that you want to profile, go over to the command line, run the profile with C profile, give it the file name, and then what you want to run. That will run it in the profile. And then SnakeViz has a command line interface that will open up your browser with the same thing so that you can do an investigation. And so the actual underlying profiler here is built into Python. You can use it at any time. But investigating the actual data that comes out of it is most easily done through the visualization like this, or through sorting this interactive table. I find it much easier than working directly with like the pstats object that I was showing a minute ago. So profile often when you're this is kind of general advice, like when you want your code to go faster, like don't guess about what's slow, because whenever I do that, I'm wrong. Actually run it through a profiler, find out what's slow, and then you can really dig in and make it fast. Thanks.
Thank you. Stuart Geiger is up next. Are you in the room? Coming up. Awesome.
I'm also out of battery power, so I have to bring my charger as well.
Oh.
I'm at 4%, so.
I hope that's a different operating system that's drained your battery there, right?
Nope, it's Windows. Well, no, it's Windows with a virtual machine that's running Linux, so that's.
We'll blame the virtual machine, that's fine. So 4.5 million downloads a month of Python for Windows sounds ridiculously huge. Let me break that down a little bit. About 1.5 million of those are Python 3.5.2, the latest version. About 1.2 million of them are Python 2.7.12, the latest one. Someone has a broken continuous integration system because the next highest version of Python is 2.7.5. Nobody should be downloading that. Please stop. Whoever's doing it, your system is broken. Please fix it. You're downloading that thing like 1 million times a month. Stop. With that, Stuart Geiger.
All right, hi everybody. I'm here to share the results of something that actually got started at a SciPy hack sprint day that I did with Jamie Whitaker, who's also in the room. Also Matthias Buissonnier, who we were looking at trying to understand the Jupyter organizations. And as you may know, with GitHub, there's a whole bunch of ways to do great statistics about repositories. For example, if you have an individual repository inside of an organization, you can get that. But at the organization level, for groups of repositories, it's sort of very difficult to do that. And one thing that we started off with just trying to actually get a map of all the contributors who had made a commit to any of the repos in any of the Jupyter family of organizations, which includes Jupyter, Jupyter Hub, the IPython, and Jupyter Attic. And so one thing that sort of came out of this was a package that's called, that I've called get.org. It's my first package actually, and it's now up on pip, so you can pip install it. And I'm just gonna kind of walk you through one of the things that you can do with that. So make sure this is the right. I had one that was trying to do it live, but live demos break, so that's why I'm just going to walk you through a notebook that's also up on the GitHub repository. So you can pip install it and use IPyLeaflet as well to display a lot of the things with maps. So you do that, you enable IPyLeaflet. You import it, it's wrapped on top of the PyGitHub package. So you import get.org, from GitHub you import the GitHub object. GHLogin is a file that I have containing my API key that is not synchronized to GitHub. Then you start off by, you can have a list or just a string of one or more mini GitHub organizations. There's a function that is getorg.orgmap.maporgs. You pass in the GitHub object that you instantiated earlier, the list of organizations, and you can have a debug level as well for how much you want to have in that. It goes through and it returns a IPyLeaflet map that you can display inline, a dictionary of the locations, and a dictionary of the metadata. And you can see it takes a long time if your organization has a lot of members and a lot of repositories, especially because there's a geolocation API we're using based on GeoPy that uses OpenStreetMap data, and that limits us to about 1 query per second. So this took about 25 minutes to get all that. And so you can go through, it goes through all of these repositories, and then you can do metadata for that. And this is a screenshot of the image you would get. Normally in IPyLeaflets, you'd be able to zoom in and out and do a whole bunch of cool stuff with that. There's also functions you can write these stuff out to different files, to CSV if you're doing that. I don't yet have GeoJSON. One thing that we use though is to output it to a single JavaScript variable that was used for another sort of thing. We wanted a more clustered map, something that looks like this. So what we were able to do is have this, have it output to a single JavaScript variable and then another HTML and JavaScript thing using a different visualization and plotting library that takes in all of those coordinates and does it. And the results are sort of up here on a github.io page, and you can zoom in and you can get sort of a nice clustered thing, and you can see different maps of anyone who's sort of made a commit to any of the Jupyter IPython family of repositories. And this can be used for anything on this. Now, any organization in GitHub. Now, some of the caveats about this as well are that it basically requires people to self-report their own locations in GitHub profiles. We found about half of the people who committed to the Jupyter family, Jupyter IPython family, did not actually specify that. So we're missing about half of the people already. And as well, this only gets their most current location. There's no historical data that the GitHub stores. So you're only getting the most recent thing about what they've contributed to. But still, it's a really fun way to get a whole bunch of maps and to sort of see at a broad level the people who are contributing to your organization. There's also a lot of, there's a module around issues that I don't think I have time to go into right now, but trying to figure out the kinds of, there's sort of things like you can, okay, 1 minute. So things where you can find right now, give me all the issues that are open in any of the repos of my organization, more than X number of days, that have more than X number of comments, that do or do not have an assignee. A lot of things you can filter with that. So as a project, yeah, please, if there's any features that you're interested in, anything that you're interested in doing analytics or things about community health about organizations on GitHub, please open up an issue, send me an email. This is, as I said before, my first project that I've been working on, but I'm really excited about it. So thank you very much.
Great, thank you. Greg, are you here? We're going to bump you up the list a little bit. You want to come up and get ready? While he's doing that, how many people here have ever used a pre-release version of Python? James has probably created some. certainly broken some badly. Sorry? Oh, I don't want to ask that. How many people are still on Python 2 and stuck there? Oh, okay, that's not as bad as I thought. I'm sorry, but.
Where do you stand? Where do you plug things?
Right here, plug just there.
Sweet.
So everyone else is on Python 3? How many people are on both? Who gets to use both? That's pretty cool. That's pretty cool. Who gets to choose that they use both? You get to pick, like, I'll do Python 3 for this project, Python 2 for that project. No, is it more of a, it's more of a, this employer says 3, this employer says 2.
Yeah,
this.
I think I got it. Thank you, though.
But the reason that I bring up the pre-release one is Python 3.6 is being developed right now. It's about to have, Alpha 3 is out, Alpha 4 is about to be cut tomorrow or the next day. Alpha 4 did not just come out today.
Oh dear. Wait, how's this work exactly?
There was an email that it's coming out, but it has not come out yet.
Okay. How do you set it to mirror? Or do I have to just look at this? Well, okay, so I'm not going to try to interact with the thing, but you can see I have, okay, so, all right, I'm going to give a short, completely off-the-cuff presentation about OCaml, which is a statically typed language, sort of similar to standard ML, and let's see, I guess the more common languages that you might have encountered that are similar to it are Go and Scala. Both of those have type inference, but in Go and Scala, type inference is kind of purely local. You still have to supply annotations on your functions, and it will infer the types of local variables, whereas OCaml has full Hindley-Milner style inference. So whenever you use a value anywhere, it can infer sort of a most specific type for all the terms in the programming language. The reason why this is useful and you should care about it is, so when you're working with Python, most of the time you're not like, if there's going to be really minimal enforcement of the contracts that the functions are supposed to provide. So if you kind of take a step back, the way that you determine whether you're using a function correctly or not in Python is kind of like, does it throw an exception at runtime? You don't get very many guarantees sort of or at compile time about what your program is capable of doing. Certain things like even indentation errors in certain circumstances can be caught at runtime, and you won't see them until you actually exercise that code path. So OCaml, one of the nice things that it has going for it is even though it has a type system that basically eliminates the possibility of runtime type errors, it also makes some concessions to make everyday programming a little bit easier. For instance, you get a magical polymorphic comparison function that you can use to compare to arbitrary values without having to specifically go in and define, like in a module, a function specifically for comparing them. In fact, that's the example that we have up here. So the displays aren't actually mirrored, so I'm going to have to look at this thing to sort of determine what I'm actually telling you. But so for instance, this is an example of an orderable type. So basically, this module, the relationship between this module and the type T, unlike in an object-oriented language, is purely by convention. Sort of if you use the alternate standard library core, most of the functions built into the language or most of the types built into the language have a corresponding module that will contain T and will contain functions that are related to that type and collectively satisfy some laws. So you can apply like a functor or something and get back a different type that's also useful. So for instance, here you can see if something's orderable, we need a type to compare, and we'd like to be able to take two items and compare them and get an integer back. So the integer being 0 if the items are equal, positive if the left one is greater, and negative if the right one is greater. So for instance, here we're basically just passing through to the built-in comparison function the standard library in OCaml is called pervasives. And so if you so you can explicitly refer to that module even though all of the values and types and other stuff contained in that module are already dumped into the global namespace. Thank you. So here you can sort of see down here we're constructing a set by sort of taking okay, so here we're not constructing an instance of a set, we're defining what it is to be a set. A set is a functor which is kind of like a compile time function. It takes a module, which is a collection of values and types in the language, and applies some kind of transformation to it. So, so what we're doing here is we're taking a set which takes some module which is orderable, and it produces, here the implementation is really simple. We don't check for duplicates. You don't have a way to get the size of the set, but you do have a way to test for membership, which is sort of our type T, kind of the center of the universe from the perspective of the set module is the set itself. And the way that you determine membership is you just take each element and you check whether it's equal to the thing that you passed in. And I actually made a mistake here using the built-in thing. We're not leveraging compare at all. Oh, I'm done? Sorry.
Thank you, Greg.
Thanks.
Does everyone thank Greg?
All right.
Okay, Tracy is up next. I don't see anyone jumping up claiming to be Tracy. Here she comes. Jump. I need you to jump. You have to jump. So this is not a Windows fact. This is simply because I seem to be the only Python core developer in the room at the moment. Alpha 4 for Python 3.6 is coming out shortly after the weekend. We need people to test it. You don't have to spend a lot of time using it. You don't have to switch to it permanently. But if you've got some sort of app, at least get hold of 3.6, run your app through it. When it breaks, please come and let us know. That's drop an email to Python list, go to bugs.python.org, report something. But it's really important for us as the developers of Python itself that as we make changes between versions, we get feedback on what has changed, what is broken, so we can fix it before you end up getting a .0 version that doesn't work. So, our next talk is Tracy Teal, non-focused board member, and she's going to be telling us about a journal for open source science.
Software.
Software?
It
says science on the board.
Sorry, yeah, they're pretty much the same. So first I want to express my previous love of Windows NT 4.0, my last significant experience with Windows. So thanks for the lightning talks. I appreciate getting to speak here. Someone did ask me to talk. So of you in the room who did not give lightning talks, who would have given a lightning talk if someone asked you to? Next time, put your name on the board. All right? I know that we should ask more people to speak, but don't be afraid to put your name on the board. Lightning talks in particular are a really fantastic way to talk about something, and if you bomb miserably, it's only 5 minutes. Awesome. Okay, so we'll see how I do. All right, so I just wanted to take a few minutes to talk about the Journal for Open Source Software. So this was a project started by Arfon Smith at GitHub and Karthik Ram of our OpenSci and some other co-conspirators. And so this is the website. And the goal of the Journal of Open Source Software is to be a developer-friendly journal. So what does this mean? So one is that this sort of idea, don't we have enough journals already? So the challenge in academic systems is that what we value are publications and grants, and software is not a publication. But it's often difficult to get software into a sort of a standard journal. There's a lot of extra work that's actually maybe not necessarily relevant to the software itself. So this is for people to be able to publish their software in a very lightweight way, so not requiring a lot of work. But the other goal of this journal, which I love, is that it's a way of enforcing, but not in a negative way, but promoting good habits around open source software. So the idea is to improve the quality of software submitted. So what does that mean? So if you are an author of a software package, it should take you less than an hour to prepare and submit your paper to JOS. That means, however, that you have adhered to the requirements that JOS has. So JOS papers should contain the following: authors, a summary, key references, and then it should be open source by the OSI definition. It should have a research application. It should also have things like tests and code documentation. So what you do is you submit your journal through a GitHub issue, and then a reviewer looks at these author guidelines. So let's take a look at one of these submissions. So these are all submissions to the JOS journal submitted as GitHub issues. So let's take a look at one of them. This one, because it has giant triangle confusograms in the title. So this person, and it's PyGTC, so it's a Pi in it. So what the GitHub issue looks like is they submit this thing, and then the reviewers assign themselves to papers. There's anyone sort of with some knowledge in the field can be a reviewer. And so reviewers say that they want to review a paper, and then they go through the paper, and there's these check boxes. So is there a conflict of interest? Does it have a repository? Does it have a license? Does the version match the GitHub release? Does it install? Does it do what it says it's supposed to do? Or if there are any performance gains, are they there? Then documentation. So there's all these checkboxes. So you can see this reviewer has already gone through, and then the reviewer started to have some questions. So then there's a conversation with the author that helps them get to the point where all those checkboxes are off. So what I love about this is that it improves the quality of software, and it's a process that's collaborative that makes the software better. So it's not a system of rejecting because you don't meet criteria, but the reviewer is active in the process of helping to improve the submission and improve the software. So I was super happy to be invited to be a part of this journal. I'm excited about where this is going to go. So if you are developing software, submit it here. It's super fun.
Thank you, Tracy.
We don't.
No? Not done? Are you done?
We don't have does it compile on Windows as a checkbox, though. Is that important?
Is that something? Can I file an issue on that?
Yeah, you can.
I'll go file an issue on that. In the spirit of participation in lightning talks, I was disappointed that only half of you will participate at FAST. Of the other half of people, if you were asked to MC the lightning talks, would you do it? Who would get up and is it just me? It's just me. I'm looking for someone funnier than me to get up and do it next time, which should be everyone in the room, frankly. You connected in?
Give me a second. Don't rush me.
So this is our final lightning talk. As I mentioned earlier,
way,
we may or may not all accidentally end up at the Thirsty Bear later on. And if you do happen to be there, we may happen to be there as well, and we can all hang out and have some fun. But now for our final lightning talk, I present to you a masterclass in self-rationalization. James Powell is going to speak on what is numFocus.
So we've all heard that this is the 20th PyData event globally. The very first PyData event occurring here in Silicon Valley in 2012 as a PyData Day on the Google campus. I've been lucky enough to be a part of many of these events. I'll give you a couple of numbers. This is the 16th PyData event that I've spoken at. Today I finished presenting the 22nd PyData talk that I've given, and this is the 10th lightning talk. So I've given about 32 talks, either talks or lightning talks or tutorials at PyData events. I clearly have no better way to spend my time than to be here with all of you. But honestly, I really do feel that way. I wanted to tell you briefly about numFocus, because even though we've had so many PyData events, people still ask about numFocus. Yesterday, I gave a long 90-minute talk about numFocus and how you can get involved and about the projects. I went into a lot of that depth. So I want to keep this very concise and tell you 2 stories about numFocus that are relevant to you, and then we'll all go get drunk. Story number 1. I hope to see all of you here tomorrow in the morning, bright and early, to see tomorrow's keynote. Megan Price, the director from HRDAG, the Human Rights Data Analysis Group, will be here speaking to us. I want to tell you how she came about being a speaker at PyData. I saw her speak in an event earlier this year, and in her talk she was saying, you know, we've done reports commissioned by the UN about casualty rates in conflict areas, where nobody really knew how many people were dying there, and we use statistical tools and statistical methods to be able to inform human rights groups that, you know, there are a certain number of casualties in this area. We really need to put a lot of focus on this. This is the scope or scale of the conflict or the refugee problem emerging from this particular conflict. And she had one throwaway line in her talk. She said, we use NumPy and SciPy for this, and I wanted to thank the folks behind that. So after she got off stage, I walked up to her and said, do you know who's behind the tools that you mentioned that you are using that were critical to your research? And she said, well, actually I don't. And I said, would you be surprised to hear that it's an organization, a single nonprofit, NumFocus, that's behind NumPy, Pandas, Jupyter, that fiscally sponsors all of these projects, that puts a lot of effort into ensuring the governance and the sustainability of these projects, that this very year is going to host, for the first time ever, a summit of summits where all of the project leaders will get together and work on issues that work across all of these projects. Now, I clearly didn't say it as such a long run-on sentence, but I tried to convey the meaning. And she said, oh, that's very interesting. I said, would you like to come and speak at a PyData event? And she agreed to speak at a PyData event. The second small story I want to give you is, I've gone to a lot of PyData events. I've spoken at many, many events. I've helped organize events like this. I've helped with other NumFocus issues. And Steve has as well. I think this is the second time he's emceed talks. This is the third or fourth event that he's spoken at. But I want to tell you that when you look at Steve or you look at me and you say, well, that's a lot of effort and that's a lot of time, one thing is this event is run by volunteers. I'm a volunteer. Steve is a volunteer. We don't work for NumFocus. We volunteer for NumFocus. We volunteer for PyData. And the effort that we put into this is the effort that we find we're able to put into this. NumFocus and PyData are always looking for volunteers, people to help out with things as simple as introducing us to speakers, things as simple as introducing us to companies who might be interested in sponsoring the event or hosting the event, things like introducing us to companies that are using the tools that want to get in contact with the people who are writing these tools and start a dialogue. Oh, I'm using Jupyter inside my company for some interesting stuff. I get to run overtime, by the way. Who are using these tools internally, and I want to contact the project developers and ask them questions about how I can incorporate this into, my commercial work. Those are small things we can do. I want to encourage all of you to think about, do you want to be a part of PyData, not just in the audience, but part of the creation of PyData, the organization of PyData? And if that's something you're interested in, I'd really like for you to come to the booth tomorrow, speak with me or Leah. We're working very hard to build a PyData community here in San Francisco to set the groundwork for another event like this next year. And we need volunteers who have any level of time commitment. So if you come to us and say, I can put in 15 minutes a week, or maybe 1 hour a month, or, I'm in between jobs right now, I have a lot of time, but I only have that time for maybe a month or two before I start my next role, but I have a lot of time right now, please let us know. We'll tell you about things we can do. And I'll give you an example of that. A couple weeks back, there was SciPy. And there was an event scheduled at the same time as SciPy, the Dato Data Science Summit. It was here in San Francisco. It was the first part of the week and the last part of the week. I needed to be at SciPy because I was giving a talk at SciPy, and it's a big event for NumFocus. The Dato Data Science Summit is also a big event for NumFocus because Dato has been a sponsor for NumFocus and for many PyData events in past. So we wanted to have a booth at both of the events. I flew out to San Francisco to help run a booth at the Data Science Summit. But I could only be there for one day. I had to fly out the very next day to go to SciPy to give my talk. There are people in this room right here who are at this event, I think, in a large part because we put out a call for volunteers. Who's willing to come to this event? We'll give you a free ticket, help us run the booth, tell people about NumFocus, tell people about PyData, have conversations with people about the open source tools, tell people why open source is important. And we have a gentleman sitting right here who helped us run that booth for 2 days. And I think part of the reason that he's here is because he said, I have part of an afternoon free. I have I have 2 days free. I can get away from work, spend a couple hours here at the event talking to people about NumFocus, PyData, and open source. And that's exactly the kind of volunteer we need. So instead of giving me a round of applause for kind of going over my time but giving my talk, I'd like you to give a round of applause to all of our volunteers who helped make this event possible. Thank you so much.
Thank you, James. And let's have one more round of applause for all of our speakers for the lightning talks. Hopefully we'll get more of you up at the next set of lightning talks we do, next PyData conference. Have a good night. We'll see you at the Thirsty Bear. See you tomorrow.